Okay, so welcome to the second class. And please, for now, while we wait for more people to come in the All right, I'll start going over this problem. Okay, so the host asks everyone if they want pumpkin pie. And so if the first logician, let's look at this from the point of view of the first logician first. So from his point of view, he doesn't know if anyone else wants it or not. However, if he doesn't want it, then he knows that not everyone wants it because he knows he high. And now from the point of view of the second logician, okay, I'm gonna draw a check to symbolize that he wants pumpkin pie. Now, the second logician, he knows that the first logician doesn't want pumpkin pie. Sorry, he knows that the first logician wants pumpkin pie. Oh, and by the way, uh, hold on a second. I'm going to rename the one that I'm using for speaking right now so I don't need to get any more messages on the screen sharing account. Okay, it's it's called teacher now. Okay, if you have any questions, please send it to the one with teacher added at the end because the other account is screen sharing and that's annoying. Okay, so I'm going to repeat what I said about the first logician because someone didn't hear it. Okay, so right for the first logician. So from his point of view, okay, so from his point of view, he doesn't know if the second, third, fourth, or fifth, or sixth logicians want pumpkin pie or not. He just knows if he wants pumpkin pie or not. And so if he doesn't want pumpkin pie, then he knows that not everyone wants pumpkin pie. So then his answer to the question would be no. However, he says, I don't know. And that means that he must want pumpkin pie. So I'm going to mark that with a check. Now, the second logician, he knows that the first logician wants pumpkin pie now. But he doesn't know whether the third, fourth, fifth, or sixth logicians want pumpkin pie or not. And so if he doesn't want pumpkin pie, then he will say no, but he says, I don't know. And now you can just repeat this for the second, third, fourth, and fifth logicians. And now the sixth logician. If he wants pie, then he knows that all the others also want pie. So he would say yes. But he says no, which means that he doesn't want pumpkin pie. And that means that the first, second, third, fourth, and fifth logicians are the ones that want pumpkin pie. 1, 2, 3, 4, 5. Okay. Are there any questions? Saying that you have a question doesn't tell me anything. Uh, are you still typing? Okay. For this problem, you're assuming that they all know if they want it or not. So he knows for sure whether he wants it or doesn't want it. Okay. So now I'm just gonna go over the homework. Well, some problems that cause issues on the homework. Okay. So first of all, we have this purple comet problem. And so we just want to find xy plus yz plus zx such that xyz satisfy these three equations. Right. Okay. So first of all, we can expand these equations. Uh, okay, a bit more space. So then xy squared plus xz squared plus xyz equals 3y plus 10z. and yz squared plus xyz plus x squared y equals 21xz plus 24x, and x squared z plus xyz plus y squared z equals 7x plus 28y. So that you basically just expand the left-hand side of all of them. And so you can add all of these three equations up, and that would give you, hold on, and that would give you x y squared plus x squared y plus x squared z plus xz squared plus y squared z plus yz squared plus 3xyz equals 31 times x plus y plus z. And this thing can factor into x plus y plus z times xy plus yz plus zx. And so you know that x, y, and z are positive, which means that x plus y plus z cannot be 0. And you can divide this from both sides, and that just tells you that the answer is 31. Are there any questions? All right. So the next problem. So Samia set off on her bike to visit her friend and traveled at an average speed of 17 kilometers per hour. And then when she's gone half the distance, a tire goes flat and then her speed gets reduced to 5 kilometers an hour. And in total, it took her 44 minutes to reach her friend's house. And so we want to find how far Samia walks to the nearest 10. Okay, so let the distance to Samia's friend's house in kilometers be d. Okay, and so the time it took her to get there in hours is d over 2 divided by 17 plus d over 2 divided by 5, because the speed gets reduced at exactly half of the distance. And when you add these together, you get 11d over 85. And so we also know that it took her 44 minutes, which means that 11d over 85 equals 44 over 60, because this is in hours. And so when you simplify this, you just get d equals 4 times 85 over 60, and this equals 17 over 6. Sorry, 17 over 3. And now Samia walks half of this, which means that she walked 17 over 6, or about 2.8 kilometers. All right. Are there any questions? All right. Okay, so on an algebra test, 10% of the students scored 70 points, another 35% scored 80 points, 30% scored 90 points, and the rest scored 100 points. So obviously, there are 100, the total number of students is 100%. And so the number of students that scored 100 points is 100 minus 10 minus 35 minus 30 equals 25%. And you want to find the difference between the mean and the median score of the students' scores on this test. Okay, so you can assume there's 20 students right here because this is the first number is 1/10. This one is 7/20. This one is 3/10, and 25% is 1/4. And all of the denominators are decreasing. There are two 70%, and there are seven 80%, and six 90%, and five 100s. And then you divide this by the total number of students, which is 20. And when you simplify this, you find that the mean is just 87%. And the median is the average of the 10th and the 11th scores. And the ninth score is 80, and the 10th score is 90, and the 11th score is also 90, which means that the median is 90%. And so the answer is just 90 minus 87 equals 3. All right. Are there any questions? Okay. All right. So this is gonna be week 2, and the topic is gonna be algebra part 2. More specifically, we're going to be going over sequences and series, polynomials, and inequalities. So sequences and series. The most basic sequence is an arithmetic sequence. And to sum up arithmetic sequences, you just have that, you can just use this, you just have this formula. And the symbol on the left is explained here. It basically means sum. It basically means sum from the variable on the bottom to the number on top of the variable. All right. And so a proof of this method, so the first step of the proof just lets s equal the sum. And then now you write s in reverse order. And then now you can add these two values up. And you know that both of these are s. So then 2s equals 2a plus n minus 1 times d, and there's exactly n copies of this, which means that 2s equals n times 2a plus n minus 1 times d. And so you can divide by 2, and that just gives you the formula. And now, geometric sequences. You can calculate any term of a geometric sequence using xn equals a times r to the n minus 1, and use n minus 1 here because a is the first term. Now, for adding geometric series, so to add all of them up, this is the general form, and this is the formula for what the sum looks like. And this formula works because of a reason similar to the one that we use for arithmetic sequences, except we don't really reverse it this time. Instead, we multiply s by r. And these are of really similar forms. And so we can just subtract them, and we get that s minus s times r equals a minus a to the r to the n, which is here. And so you can find, using this, you can find that s equals a times 1 minus r to the n over 1 minus r. And here's your first example. And send answers to through the chats. Okay, so for this problem, note that the fact that S10 exists, it doesn't really matter. And so all that really matters is the fact that every term is the sum of the previous two. And so using this, you have that S7 plus S8 equals S9. And that means that S8 is 110 minus 42, which equals 68. All right. And now from here, you have that S6 equals S8 minus S7 equals 68 minus 42 equals 26. And you have that S5 equals S7 minus S6 equals 42 minus 26 equals 16. And so you have that S4 equals S6 minus S5. And you already know what these two are from the previous two lines, which is 26 minus 16. And so the answer is 10. Are there any questions? All right, here's the next problem. I'll just start going over this. Okay, so we can just try going up. I can't highlight. Sad. Okay, so you can just try going up. So you have that a1 is just 2 times a0 minus 1 because a0 a0 is clearly more than 1/2, and so a1 equals 5/7. And this is clearly still over 1/2, so then a2 is 2 times 5/7 minus 1, which is 3/7. And now 3/7 is less than 3/7 is less than 1/2, and so you have that a3 is 2 times a2, which equals 6/7. And so from here, you see that the sequence repeats every 3, which means that a0 equals a3 equals all the way to a 2007. And it all equals the same thing, 6/7. And so a 2008 equals just equals 5/7. All right, are there any questions? Okay. All right, here's the next question. And I have a lot more stuff to cover today, so I might give less time for the rest of the problems. Oh, right. And something to know is that the sum of an infinite arithmetic sequence is always a divided by 1 minus r, where a is the first term and r is the common ratio.
What's that sound?
Which sound?
Yeah.
Someone leaving or returning.
I'm pretty sure that's just when someone exits and then re-leaves. exits and then re-comes in.
Oh, it makes that sound.
I'm not sure if I'm not sure if you're talking about that sound, but that's one of the sounds that I'm hearing.
Oh, okay. It's not December 6th. It's December 5th.
What?
It's December 5th, not December 6th.
That's probably just a typo
Oh, okay.
because this just auto applies the same date to all sides. All right, I'll start going over this. Resume. Resume. Okay. So yeah. Okay. So the first half of the first sentence basically is just saying that a divided by 1 minus r equals 7. All right. And now the second half of the sentence, it basically is saying that ar plus ar cubed plus etc. equals 3. And this is an geometric sequence with first term ar and common ratio r squared. So ar divided by 1 minus r squared equals 3. And now you can multiply both sides of this equation by 1 minus r squared and use difference of squares. So ar equals 3 times 1 minus r times 1 plus r. And from this equation, you have that 1 minus r just simply equals a over 7. So you have that ar equals 3 times a over 7 plus 1 over r. And you can divide out the a and multiply both sides by 7/3. So 7/3 r equals 1 plus r. And so r equals 3/4. And a equals 7 times 1 minus r, which, since you know that r equals 3/4, tells you that a equals 7/4. So a plus r is 3/4 plus 7/4 is 5/2. Are there any questions? All right, guess not. All right, I'll start going over this. Okay, so first of all, you can see that. Okay, so it says for all positive integers n less than or less than 2002. And so you can factorize 2002 into 11 times 13 times 14. And so if n is divisible by 13 and 14, and is less than 11 times 13 times 14, then n must be 13 times 14 times 1, 13 times 14 times 2, 13 times 14 times 3, etc. to 13 times 14 times 10. And similarly, for an equals 13, you have that the number must be 11 times 14 times 1, 11 times 14 times 2, all the way to 11 times 14 times 12. And then you can do the same thing for n an equals 14, and it's when 11 times 13 times 1, 11 times 13 times 2, all the way to 11 times 13 times 13. And you know that none of these overlap because 11 times 13 and 14 are all relatively prime to each other. So the first time of these any two of these will overlap is at 11 times 13 times 14, which is 2002, and you have that the restriction that for integers n less than 2002. So you have that the sum is just 11 times 10 plus 12 times 13 plus 13 times 14 plus however many numbers are left times 0. And when you do the addition, you just get that this is equal to 448. Any questions? All right. If not, I'm going to skip a little bit. Okay. So onto polynomials. So a polynomial is basically just the sum of a few terms, and terms are just the product of a few variables and constants. So the standard form for writing a polynomial is basically it means to put the terms with the highest degree first. And for terms with equal degrees, then it doesn't really matter what order you put those in. All right. And here's another example. This should be pretty easy. All right, I'll start going over this. Click. Okay, so for number 1, this is simply just 4 plus 9x squared plus 8 minus 7 times x cubed plus 12x to the 5th. And when you write this in standard form, you simply get 12x to the 5th plus x cubed plus 9x squared plus 4. All right, and for this next one, by the distributive property, you have that this is 2n squared plus 3n minus 4n minus 6, which equals 2n squared minus n minus 6. All right, this should have been pretty easy. Okay, so more about polynomials. So the quadratic formula. So there's a shorthand notation for plus or minus, and it looks like this. Basically, what it means is that there are two answers, one positive and one negative, or plus whatever, minus whatever. And so this is the quadratic formula. And it's the general solution for any quadratic of the form ax squared plus bx plus c. And yeah, this is pretty important, so you should remember this. All right, and Vieta's formulas. So they are used to relate the sum products and pairwise products, three-wise products, etc., to of a polynomial to its coefficients. And so the simplest and most well-known form of this is in quadratics. So if you have a quadratic of the form x squared plus ax plus b equals 0 with solutions p and q, then you know that x squared plus ax plus b equals x minus p times x minus q. And so by using the distributive property to expand the right hand, you have that x squared plus ax plus b equals x squared minus p plus q times x plus bq. And so the sum and products of a roots of a quadratic of the form ax squared plus bx plus c with root r1 and r2 are simply r1 plus r2 equals negative b over a, and r1 times r2 equals c over a. And so here's the first problem. And this was put in the polynomials part because the discriminant is quite important for some problems, because it can be used as a way to check if the roots of a polynomial are real or not, and integers are not. And it says Gordon because Gordon was the one who made this problem. All right, time to go over this. So you in this quadratic, you have that a equals the coefficient of x squared, which is 1, b equals the coefficient of x, which is 1, and c equals 1. So b squared minus 4ac equals 1 squared minus 1 times minus 4 times 1 times 1, or negative 3. Yeah. And are there any questions? Okay. Next one. All right. So the reason the discriminant is important is because I think you might already realize this, but here's the quadratic formula again. And the discriminant is this part. Well, the square of this part, but yeah. And so if there's only one solution, that means that you have negative b plus minus 0 over 2a. Because if this were anything other than 0, then you would have two roots. And so you have that b squared minus 4ac equals 0. And that's the discriminant. So the discriminant of every quadratic with the double root is just 0. Okay, this one is a lot harder than the previous two questions. Actually, in the interest of time, I'm just gonna skip this one. Okay, here's the next one. The previous one has a short solution, but finding it is pretty hard. Alright, so I'll be going over this now. So you want to find the sum of the reciprocals of the roots of 2003 over 2004x plus 1 over x equals 0. And first of all, you can clearly see that x equals 0 is not a solution, because then 1 over 0 is not possible, and even if it were, then yeah. So you can multiply both sides of this by x, and this gives you that 2003 over 2004 x squared plus x plus 1 equals 0. And oops. And you can also manipulate the sum of the reciprocals of the roots. So it's 1 over r1 plus 1 over r2. And when you put this over a common denominator, you get that it's r1 plus r2 over r1 times r2. And you can easily find both of these by direct viatas. And so r1 plus r2 is negative 1 over 2003 over 2004, which is negative 2004 over 2003. And similarly, r1, r2 equals 1 over 2003 divided by 2004, and which equals 2004 over 2003. So r1 plus r2 over r1 times r2 equals negative 2004 over 2003 divided by 2004 over 2003, which is negative 1. All right, so are there any questions? All right, I'll start going over. Oh, okay. If you don't have questions, you don't need to say so. Okay, so the final topic for today, inequalities. And so inequalities are relations of variables, and they use greater than, less than, greater than or equal to, less than or equal to signs in general. So for two numbers a and b, if a is greater than b, a is greater than b. Okay, I'm assuming you know what these mean already. I'm just gonna assume all of you know what that means. All right. So some properties of inequalities are, if a is greater than b, then if c is greater than equal to 0, then a plus c is also greater than b. And if a is greater than or equal to b, then a plus c is greater than or equal to b, where c is greater than or equal to 0. And if a is greater than or equal to b, and c is greater than 0, then a plus c is greater than b. And another fact about inequalities is that if a plus b is greater than or equal to c, and d plus e is greater than or equal to f, and a plus b plus d plus e equals c plus f, then you have that both of these are actually equalities. And this can be useful sometimes. All right. So solving inequalities. So in general, when you're solving inequalities, you can add or subtract from both sides without changing the inequality sign. But when you're doing multiplication, division, or taking the nth roots, then you need to watch out for the signs. Specifically, when you multiply or divide by negative amounts, then you flip the sign. And you also need to be careful about boundaries of solutions. And for example, if you have x is greater than 2, then x equals 2 does not satisfy the inequality. And one way to format solutions for inequalities is to use interval notation. And in this case, closed bounds use square brackets, while open bounds and bounds at positive infinity or negative infinity use parentheses. And so they provide one example here, and another example is if x is less than 6, interval x is less than equal to 6, then the corresponding interval notation is negative infinity, comma 6 square brackets. Yeah, okay. All right, here's your first problem. All right, so the answer to this question is E. I'm just gonna first say that. And so y plus x squared. And this is wrong because you can have like y equals negative 0.5 and x equals 0.0001. And clearly this is negative. And for b, you can have an almost identical situation. So y equals negative 0.99, x equals 0.000001, c equals 1.01, and in this case, you still have that as negative. And for c, if you have that, for example, y equals negative 1 half, then negative 1 half plus 1 over 4th is less than 0. And for d, if you have that y equals negative 0.1, negative zero point 0.1 plus 2 times zero point zero 0.01 is negative zero point zero 0.08, which is still less than 0. And the answer is E because assuming because you can set Z equals as close to 2 as you want, and in fact you can set Z as close to its lower bound as you want, and Y as negative as you want, and you can still have that it's always positive because Z is greater than 1 while the absolute value of Y is less than 1. All right, and so the answer is E. And arithmetic mean geometric mean inequality. And this is quite useful. And it's often abbreviated to just AMGM. And it basically states that for n non-negative real numbers, the arithmetic mean is always greater than or equal to the geometric mean. And algebraically, come on, algebraically, it just looks like this. And this is what the arithmetic mean is, and this is what the geometric mean is. And the equality case is when all the terms are equal. So it's when A1 equals A2 equals all the way to equals AN. Yeah. And there are easy ways to prove this, but you can search it for yourself if you want. All right. Here's an example of a problem that uses AMGM. Oh, okay, so apparently I got it. Someone sent a request to see AMGM, so here it is. If you want, I can screen share just the algebraic form with the problem, but eh, Pretend you didn't see the solution I'm pre-writing. Oh, uh, since no one has managed to solve the problem so far, I'll just show the first line of the solution. By the way, there's someone whose mic is on. Alright, I'll just go over this now. What that up? Okay, yeah. So the first line of the solution was I already showed you. And so you know that A is positive, so these are both greater than 0. And so you can apply AMGM to this. And that tells you that 1 plus, sorry, A plus 1 over 2A is at least 2 times root 1 times 1 over 2A, which is root 2. And equals is when A equals 1 over 2A, which is when A is root 2 over 2 or 1 over root 2. And so you can just plug this back into the original thing. And so the maximum value is 2 minus root 2 over 2 minus 1 over 2 times root 2 over 2, which is 2 minus 2 times root 2 over 2, and that equals 2 minus root 2. So the answer is 2 minus root 2. And yeah, okay, so we won't go over any more problems for today's class. And so the lecture and the homework and stuff will be posted over the next couple of days. And yeah, and thank you to my brother Gordon for being a wonderful TA. And that's it for today's class. And yeah, you can leave now if you want. Or if you want to ask questions, you can ask them now.